Good afternoon. I am Jen Fontaine and I am your facilitator for today. And the name of our session is Building Algebraic Fluency Through Diagrams. So before we get into today's session, just a few housekeeping things. We're not going to need any cell phones. We will not need any technology. The only thing that you will need for today's session is your mathematical practices handout as well as your participant handout. So we can move the technology to the side. So the goal of today's session, we actually have two goals. So the first goal is you will understand the use of a tape diagram to aid students in algebraic fluency and modeling of word problems. And the second goal is that you will be able to guide a struggling student through the modeling stages of a word problem to bridge their ability to represent the problem algebraically. So before we begin, our first activity is just 1 minute. So I'll give you a minute to get out of your seats and go partner with another person and to talk about what strategies you have used to bolster students' proficiency with the algebra necessary for success at your grade level. Oh, I want to mention this last thing. I will raise my hand whenever I need to get your attention and to bring the group back together. So with that being said, thank you so much for participating in the out of seat activity. I heard some great responses. I heard tape diagrams. I heard fluency drills. I heard spiraling of content. So thank you for participating in that 1 minute activity. So now we're going to get into the next phase of the session. And I am going to act as a teacher while modeling the problems. And you are going to participate as middle school students. So I want you to pay attention to the teaching decisions so we can discuss them after the modeling sequence. So I'm going to focus on the RDW process, which stands for read, draw, and write. We're going to also tap into the mathematical practices. The main one are mathematical practice 4, where we're going to be modeling with mathematics. Mathematical practice 5, we're going to be strategically using tools, and mathematical practice 7 is the utilization of structure. So I'm going to start off by modeling a few problems. I'm going to pick one problem per grade level. So we'll do one for 6th grade, one for 7th, as well as one for 8th. So just pay attention to how I actually go through the process. So for the first question, again, we are going to apply the RDW process. So I would ask you to read the first question, which is grade 6. It starts off with Hannah. So I'm going to work out this question, but we're going to work on this question together. And what important information we have, what important information do you see in question number 1?
That there's a need to determine angles, so something is missing. That the angle of the corner measures 90 degrees, and that another piece of the tile floor has a measurement of 38 degrees.
Okay, perfect. Thank you. So what we're going to do is we are going to work on this problem. We're going to draw a diagram. We've already done the R of the RDW process. So we've already done the R. Now we're going to draw. So I know that it's made up of 2 angles. I know it's a right angle. So I'm going to draw that square. We're missing one of the angles, and we are given one of the angles. So I would make the connection between this diagram and being able to write an equation. So is there an equation that you would write?
The equation that I have is 90 degrees minus 38 degrees equals x degrees.
Equals x degrees. Okay, that looks great, but that looks like more of a step 2. So let's back up a little bit, and I'm going to write the equation over here that represents this diagram. So we know that we have x plus 38 degrees is equal to 90 degrees. So now we're going to move into the next phase because our goal is to isolate the variable. So if I have a positive 38 that I want to get rid of, I need to ensure that I subtract 38 degrees from both sides. What do you get after you subtract 38 degrees from both sides?
52 degrees.
52 degrees. Perfect. So one thing that we want to make sure of is we've read the question, we've drawn a diagram, we've actually written an equation. Lastly, let's make sure we write a complete sentence. So what is the measure of the unknown angle? The measure of the unknown angle is 52 degrees. Okay, so that's the first question. That was a grade 6 question. So let's move on to a grade 7 question. And just to ensure that we have time to get through the questions, if you have any questions, just write them down and we'll address them at the end. So the next question, question number 3, which is grade 7, it talks about Henry, and he has a total of 16 feet of lumber to make a bookcase. We know that the left and the right side are 4 feet high, and there's 4 other shelves that have the same length, so we're trying to figure out the length of each shelf. So I would start off by drawing a tape diagram, which represents the total. We know the total is 16 feet. And I know to break this 16 feet up into 6 pieces. I know that the left and the right are 4 feet each. And I know that the other shelves have the same length, so I can represent them with the same unknown variable. So what we can do, well, I'll do that in a second. We can represent this as an equation as well. But we know that the 4 times 2, those have a measure of 8. So I know this has a measure of 8. So if I subtract 16 minus 8, I know that these 4, and I'll erase it to write a little bit further under, but I know that the length of those 4 shelves is a total of 16 minus 8 is 8 divided by 4, which is 2. Okay? And I got the 8 from the 4 times 2 over here. So with that being said, just to ensure that we're using complete sentences, we know each shelf is 2 feet long. So the beauty about this question is this can also be represented with an equation. So based on the information that is given, we know that there's a total of 16. We know that 2 of the side lengths, 2 of the shelves are 4 inches each, so that's 8. And the other 4, they have the same length, so I know that whatever the length of that last shelf is going to be times 4. So our goal is to isolate the variable. So the first thing that we want to do is we want to subtract 8 from both sides, which is equivalent when we subtracted 8 from when we use the tape diagram. So now I know that 4s is equal to 8. We now want to isolate the s, so we're going to multiply both sides by the reciprocal. So s is equal to 2. So what I appreciate about this question with the multiple ways to approach it is you give struggling students an opportunity to be successful. Sometimes students can't easily build their equations, but a lot of the times with my experience, students really do understand tape diagrams. So giving your struggling students multiple options so that they can be successful. All right, so let's move into the last question. Again, there were like 7 or so questions, but I just wanted to pick one for each grade level to ensure that we don't run over too much time. So we're going to complete question number 5. So question number 5, we're looking for different angle measures. The question gives us some information as far as the right triangle. So going back to the RDW process. So we're going to read the question and then we're going to draw a diagram. So we know that one of the angles is 10 more than the other angle. Okay, so let's say we'll let this angle be x degrees. This will be 4x plus 10 degrees. So what do you know about this particular problem? How can we approach this question? Do you know how to do this one?
No, I don't know.
Okay, so let's just try to go back to some prior knowledge. Do you remember the sum of the angles in a triangle?
180.
180 degrees. Perfect. So we know we have three angles. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equivalent to 180 degrees, and that's because of the triangle sum theorem. So the problem told us that the third angle is the right angle. So I'm just going to go in and fill that in, and then it doesn't matter what I let to be angle 1 and angle 2. Okay, so now we're going to combine our like terms. All right, so now we're going to isolate the variable. So I need to get rid of this 100 degrees. So I'm going to subtract 100 degrees from both sides. Then we have 5x is equal to 80 degrees. Now we're going to multiply both sides by 1/5. And we know that the x is 16 degrees. So be sure to remind your students that we're not done here. Because a lot of the times the students they get an answer and they want to be done. Well, we know that the measure of angle 1, we said angle 1 was x, so we know that's 16 degrees. We know measure of angle 3 was 90 degrees. So we know that the measure of angle 2 is 74 degrees. After you plug in the x times the 16 times 4, get 64 plus your 10. Okay? So what I appreciate about this question is there is a perfect diagram that matches the question, but you can also build an equation to support your struggling students through it. Because a lot of the times with my experience is if the kid can't get a diagram, they can more than likely get an equation and vice versa. So now we're going to discuss a little bit of the actual process that I went through and something that you can utilize with your students as well. Depending on if this is day 1 of content, then you want to do a lot of guiding. You want to do a lot of modeling with the students, and then you will go into allowing the students to practice independently. So are there any questions or anything that you noticed as far as how I delivered the process of the actual approach of the word problems?
No, I think that giving them the ability to read, draw, and write, or giving them that instructions allows them a place to start. Mm-hmm. Because many times if you're doing a word problem, you may not even know where to start. Mm-hmm. But if the student understands, okay, let me read this, highlight maybe what's important, and then draw out what I can, mm-hmm. then it will help me get into the writing portion of equations and actually determining the answer.
Right. Perfect. Thank you so much. So that is the end of my session. I don't want to take up too much time, but I appreciate your time. And I am, again, Jen Fontaine, and I just delivered the session entitled Building Algebraic Fluency Through Tape Diagrams. Thank you.